This is topic N35, laws of exponents. Before we go ahead and do some examples, let's just review the laws of exponents. When your bases are the same, then you're going to add your exponents. Okay? Whenever your bases are the same with division problem, then the law of exponent says to subtract the exponent. Keep your base and subtract your exponent. Okay, on this example here in the middle, any number raised to the 0 power is 1. Okay, and then if you have a base to an exponent raised to another exponent, then the rule is going to be multiply. The law of exponent says to use your base and multiply the two exponents. On the last example here, if I have a negative exponent, okay, then to make your exponent positive, you're going to take the reciprocal. All right, also note that if I started off like this, then that's going to be equal to b to the x. So you just take the reciprocal to make your exponents positive. All right, the power chart, this is a table of values that would be really helpful for you to memorize. So just make sure that you know that 2 squared is 4, for example. 2 cubed is 8. 2 to the 4th power is 16. 2 to the 5th power is 32. 2 to the 6th power is 64. And then the same with the others all the way up to 10. So just make sure that you memorize those. All right, we're going to use the laws of exponents to simplify each of the following. Since this is a multiplication problem, we're going to keep our base and we're going to add our exponents. So b to the 13th power. Okay, number 2, the bases are the same, so keep your base and subtract your exponents. So b to the 4th power. Right, on number 3, we have a quantity raised to another exponent, so keep the base and multiply the two exponents together, so that's b to the 12th power. All right, I have a negative exponent, so I'm going to take the reciprocal and turn the exponent positive. Number 5, we have added a couple of more numbers in, but the laws are still the same. We're going to add the exponents and multiply the constants. 3 times 4 is 12. A to the 1st power times a to the 3rd power is a to the 4th power. Okay, on number 6, we have a fraction. 27 over 45, the common factor is 9, so 27 divided by 9 is 3. 45 divided by 9 is 5, so that fraction reduces to 3/5. And then we're going to apply the laws of exponents where the base is a. Okay, the difference between the 3rd power and the 4th power is 1, so a to the 1st power goes on the bottom. B to the 3rd power on top, it's the only power of b we have there. And then c to the 5th power over c squared is going to reduce to c cubed. Okay, just a helpful little hint there. Wherever your exponent is the largest, that's where the answer is going to go. You're going to find the difference and then put your answer where the bigger exponent was to start with. All right, on number 7, our exponent is 3, so we're going to use the 3 on every number inside the parentheses. Negative 3 cubed, x cubed, and y squared cubed. All right, that's going to give me negative 27 x cubed y to the 6th power. Number 8, this is a division problem and the bases are the same. So x to the n minus n is x to the 0, which equals 1. On number 9, we have the same base of 5. So 5 to the negative 5 plus negative 3. That's going to be 5 to the negative 8 power. Since the exponent is negative, the reciprocal is 1 over 5 to the 8th power. And then on number 10, we're going to start with the numerator here. This is a multiplication problem. The bases are both 2, so 2 to the 8 plus negative 5 over 2 to the negative 4. Okay, so that's going to give me 2 to the 3rd power in the numerator over 2 to the negative 4 in the denominator. And then with division, the bases are the same, so I'm going to subtract the exponents. 3 minus negative 4 is going to be 3 plus 4. So that's 2 to the 7th power. Moving on to topic N36, negative exponents. We've already been talking about this, so just be reminded that x to the negative 1 is equal to 1 over x. But also, if you start off with 1 over x to the negative 1, that equals x to the 1st power. Okay, so number 1, the fraction 2/3 raised to the negative 3rd power, both the numerator and denominator will get the exponent of negative 3. Okay, since they're both negative, we're going to take the reciprocal in order to turn them positive. Okay, 3 to the 3rd power is 27. 2 to the 3rd power is 8. Number 2, both exponents are negative. The bases are different. So I'm going to start off by taking the reciprocal. 3 to the 3rd power over 4 squared is going to be 27 over 16. Okay, number 3, we have a lot of different things going on here. So we're going to go ahead and look at where the bases are the same number. X to the negative 2 minus negative 3. Y to the 3 minus 2. And then Z to the negative 1. Okay, negative 2 minus negative 3 equals x to the 1st power. 3 minus 2 equals y to the 1st power. And the z has a negative exponent, so we're going to put that in the denominator. So we don't really have to put the ones. It's going to be x, y over z. Okay, on example number 4, we have a couple of negative exponents going on here. Notice that all 3 base numbers are different. So our goal is more to simplify and reduce using common factors. So I'm going to start off rearranging 2 to the 8th power times 16 to the 1st power over 4 to the 5th power. Okay, I know that 4 squared is equal to 16, so I'm going to rewrite this 2 to the 8th power times 4 squared over 4 to the 5th power. All right, now since I have the same base of 4, I can subtract those 2 exponents. Okay, and I'm going to end up with 2 to the 8th power over 4 to the 3rd power. All right, now I'm going to go ahead and expand 4 to the 3rd power, and I can rewrite 2 squared times 2 squared times 2 squared times 2 squared. Each one of those has a value of 4, and if I add them up, then it equals 2 to the 8th power. So canceling 4 with 4, okay, that's going to give me 2 to the 2nd power, which is 4. Okay, on number 5, all we need to do is rearrange according to the exponents. I have 4x cubed over y to the 6th power. Since it was negative, I took the reciprocal on that one. And then each one of these is going to be multiplied times negative 3. So negative 1 times negative 3 is positive 3. And 2 times negative 3 is negative 6. I'm going to put that in the denominator. Okay, notice that these are like terms because their exponents are exactly the same. So that's going to be 4 plus 1 equals 5, x cubed over y to the 6th power. Okay, on number 6, we're going to use the distributive property. Okay, 3 times 2 is 6. X squared times x to the negative 2, that's x to the 0. So that's just 1. We don't have to put times 1. And then y cubed. Okay, and then the next one, 3 x to the 3rd power, y to the 2nd power, because 3 minus 1 is 2. Okay, and then the last one there is going to be 3 x squared y to the 7th. Okay, on number 7, every number is going to get a negative 1 for an exponent. So negative 3 to the negative 1 power, x cubed to the negative 1 power, and y to the 5th to the negative 1 power. Since everything's a negative exponent, the reciprocal is 1 over 3 x cubed y to the 5th. And this 3 should have been negative because it started off negative. That negative 1 exponent did not affect the sign on that negative 3. Okay. Okay, and the last example here is distributive property again. Okay, so negative 2 times 3 is negative 6. X squared times x is x cubed. And then y. Oh, hold on a second. I made a mistake. The 2 and the negative 2 there, I didn't see that. So we're going to add those up. 2 plus negative 2 is 0. Okay, so x to the 0 equals 1. So that's going to be negative 6 and then y squared. And then we've got negative 2 x to the 3rd power, and then the y to the 1st power times y to the negative 1, that goes to y to the 0 again, so that goes away. And then negative 2 times 3 is negative 6. X squared times x is x cubed. And then y times y is y squared. So you just need to keep everything straight and really watch the multiplication and the laws of exponents when you're multiplying.